industry utility, ways to maintain the efficiency sustainably. At the same time, let us see to it that your utility equipments are not getting derated or not running inefficiently, and how to run the same efficiently by monitoring only. Bureau of Energy Efficiency always says monitor to target the energy reduction. Here, monitoring of the equipment, especially on the energy influencing parameters, or what are all the deviation parameters that is happening in the energy readings at the input, at the utility and at the output of the utility, how this can be monitored to have a control of the utility to deliver efficient utility service to the industry, to the plant sustainably as such. So, the ways to maintain the industry utility efficiency and restoring the rating sustainably. Your industry is like motor or pump or blower or compressor or cooling tower, gets derated due to many factors at the input stage or at the intermediate stage or at the output stage. The motor gets derated due to many parameters at the inputs. I am talking about the 3-phase motors in the plant only, and the heat dissipation inside and outer skin of the motor and at the output stage of the motor, at the intermediate transmission from the motor to the machine deliverable as such. The pumping system suffers due to the input stage, the internals of the pump also makes a lot of difference now during the routine and condition monitored maintenance and at the output stages. The blower as a system faces efficiency drop at the input and at the internals, going for an energy efficient internals of the blower system, either an axial flow fan or a centrifugal impeller as such, and at the output stages. The compressor efficiency drops at the input stage, at the internals of the compressor, that is the generation efficiency of the compressor, and at the output delivered to the compressor house to the compressed air treatment. The compressed air treatment holds the key here to maintain a compressed air system health for the plant as such. The cooling tower, the heat transfer is affected by the internals and getting derated due to this heat rejection is getting derated, because 80% of the heat transfer is happening at the fills what you are using inside the cooling tower, and if it is getting choked, automatically the heat transfer does not happen, and whatever is the input splash or at the output the rain, the spray that is going to the drain, the 80% is at the PVC fills where the fills are there, and the fills need to be conditionally monitored as such. Also, the production machines face derating due to the auxiliary subsystem sizing and working. When your equipments or process are getting aged, deviating from the best operated NAPs, the output production automatically reduces and the exhaust increases. This is the main point which I wanted to discuss here. Once the input is given either excess or the output gets reduced, automatically the exhaust goes up. So, it is time to routinely monitor the exhausted fluid parameters, mostly a gas or mostly air, especially in the blowers or compressors, and in content and movement also. Higher the exhaust shows, the output gets derated for the given utility and the efficiency drops drastically, and the specific energy consumption for the given utility goes down, and it gives a lesser productivity given to the process as such. So, visualize and monitor the energy content and the movement at the incoming of your system and in between the process. You can see the diagram. You can see the previous diagram also. The industry process needs what are all the energy inputs like energy, water, chemical, raw material, but the emission from the process and the emission from the combustion. See, ultimately all the total process gets affected, and in case of any unbalance in the inputs or in case of any deviation in the inputs, and the product gets derated or reduced, and the exhaust emission goes up either from the process or in the combustion, and the waste also, liquid waste or this direct or energy waste also increases as such. The same thing if you see as a block diagram for the given plant, one is the energy and the useful energy is the output, and the raw material is there from the right side, and the losses increases and the output decreases as such. So the utilizing the 80-20 Pareto concept to study the auxiliary and utility systems and actions, how they influence the energy efficiency health parameters of the given process machine as such. Coming to the, I am just talking about different aspects of the utility like motors or blowers or compressors or pumps or cooling towers, whatever it may be. You see each and every utility is facing derated condition over years. It need not be say after 10 years or 15 years, sometimes the motor gets derated very faster also. One is the loading, the efficient loading zone is around 60 to 80% for the given motor. You just check for yourself whether your motor is loaded by the average kWh delivered, that is consumed by the motor over a period, over a day or over a week or a month or a year. You just study it, and if you are in the average of 60 to 80, it is always relatively efficient compared to the inefficient zones like less than 50% and all. Coming to the voltage unbalance that comes at the input of the motor terminals, almost 3% of unbalance at the see it's a 3-phase motor, it leads to motor derating by 10%. This we have to keep in mind. Many of the input unbalance at the voltage, automatically the current unbalance gets amplified and the motor gets derated. So why the motor is getting hotter means it can be due to warm, see the motor can be only warm, it cannot be hotter or it cannot be idling, and it cannot be cold also. So the shaft RPM measurement, what is rated and what is running the RPM. The thermal imaging scan of all the axes like let us say 12, 3, 6, 9 and 12, and if you see at the driven and non-driven, this difference in temperature definitely indicates the motor is thermally getting overheated to deliver the output gets derated. The lubrication also, already the conventional greases are going out and the specialty lubricant greases have already come into play in many of the latest motors and machines, and the industry has adapted to the latest specialty based lubricants, polyurea thickened lithium complex grease as such. The ventilation, if the totally enclosed fan cooled motor, if the fan is not effective enough, maybe you need to even change the fan so that the motor is getting an efficient cooling across the fins of the motor. That is more important. Next comes the motor, what is the torque delivered by the motor and what is the torque demanded by the machine. Especially in the variable torque loads, the difference is very much seen, and this difference can be definitely be focused on, and thousands of case studies has been done by resizing the pulleys and using a energy efficient cogged belts which has a more power carrying capacity, and this VFD already is there. VFD is facilitating to reduce the torque gap between the demanded torque and the demanded torque, and what is the torque given by the motor and what is torque demanded by the motor. This achieves and gives an energy savings of 10 to 20% in all your variable speed blowers as such. Coming to the motors, there are contribution of, I don't say motor failure, the motor is put to strain. It can be low, medium or high. The low steps definitely we are taking care and definitely we are attending to it. But in case of medium or high, let us say the power quality like voltage fluctuations or the voltage imbalance are due to corrosive contacts at the incoming of the motor from the SSB to the motors. And the maintenance side, a defective bearing, definitely the heat dissipation will not be there and definitely the motor gets heated up more, and misalignment or the mechanical looseness on the grouting of the motor. See, these are all the high input, it has a higher contribution towards the motor overstrain, and if it is not attended to, it is going for motor failure also. So we have to take care in your routine maintenance why the motor is getting derated, either due to power or power quality or due to the power inputs not equally given to the motor or the operation and maintenance on the mechanical side of the motor as such. So coming to the compressed air, see the compressor system, if you see the heat of rejection, it's almost 70 to 90%. See, overall it is around 95% for meant for heat recovery, but almost 70% it is getting lost in the exhaust air. So when the most of the energy, 70% of the exhausted air, especially on the screw air compressor we are talking about now, is exhausted from the compressor, this needs to be monitored. How many of our plant personnel we are monitoring, plant maintenance personnel monitoring the static pressure or the temperature at the exhaust duct. See, exhaust duct, whatever the OEMs have given, let us size the duct correctly and pakka dimension wise, let us have the duct expanded in such a way that the air is taken optimally at a lesser static Pascal and it is delivered outside, the hot air is delivered outside. The healthy parameters are that indicate the compressor's health. The static Pascal at the exhaust of the exhaust duct of the compressor, as well as the temperature at the exhaust duct. That is why many of the plant personnel even started insulating the duct also, exhaust duct, but that needs to be expanded and it has to be a short way out to outside the atmosphere, so that the compressor house is always kept ambient at the ambient temperature. So let us try to monitor the exhausted parameters, air parameters. 70% of heat of rejection is there. Once it is monitored in temperature and the static Pascal, you can also check with the OEM, compressor OEM, what is the norms and where we are maintaining it as such. It is a band, we have to maintain it. So why this aspect has come now is, let us take the boiler subsystem. The boiler efficiency is worked out in such a way that flue gas temperature, exhausted gas temperature, the pressure or the temperature or the oxygen content in the flue gas, all these things are monitored by many of the industries to measure the boiler efficiency by indirect efficiency norms as such. So likewise, if we horizontally deploy this to blowers or compressors or pumps, let us say how many of the industries are monitoring the static pressure at the suction or delivery of the, and at what static pressure, the unproductive, that is exhausted to the atmosphere. See, what all the axial flow fans, what all the centrifugal blowers, definitely this needs an expanded suction at the inlet and a delivery cone or a discharge cone at the outlet that maintains the static pressure to the optimum. And let us also listen to the OEMs who have given the blowers and fans what is to be maintained, and let us try to maintain it. Since the compressor, the majority of the heat is exhausted to the as a heat of compression, let us monitor first the temperature and the static pressure of the exhausted air. Monitoring the above first, definitely we can optimize. On a healthy compressor, we know what is the condition, and let us say the post-operative cooler, post-air cooler on the compressor hood, it gets choked, it gets derated, automatically the exhaust temperature and the exhaust static pressure drops and the temperature goes up. So here the OEM can give the band for each model or each machine, what is the pressure band or what is the temperature band that can happen at the exhaust of the compressor hood, and so that we can monitor it, and definitely we see to it that the compressor is healthy, is maintained sustainably over years as such. You can see many of the users, plant users, have given a type of chute like duct. Instead of that, an expanded duct. The dimensions are already given by the OEMs. Let the user go by the dimensions given by the OEM. Expanded duct at a short distance to the compressor house, out of the compressor house, that matters more here. So when the post-air cooler gets choked, automatically the static pressure drops as such. So, and definitely the temperature also goes up at the exhaust duct as such. So these are all the areas. Once we monitor the exhaust duct, we will definitely know whether the compressor is healthy. Let us say we are trying to maintain the health of the compressor on different aspects. Coming to the input stage of the compressor, this I have already discussed, but still I just wanted to say, because why many of the people or many of the plant maintenance personnel are not taking this as seriously. See, if we start monitoring above 50 HP compressor, if we start monitoring the input Pascal drop across this intake filter, air intake filter, this is a 110 kilowatt, this is a, 110 kilowatt screw compressor delivering almost 720 CFM at the rated output, but because of choke in the air intake filter from 100 Pascal, normally it is supposed to be maintained as a fresh filter and it is to be monitored regularly, routinely. If this is allowed to choke to 2700 Pascal, 13% difference in volume delivery, the discharge delivery drastically dropped here. Thanks to the Synthen flow metering details, definitely it is worth to monitor and definitely clean the air intake routinely. This is a zero cost or a low cost exercise that we can definitely employ upon it. Coming to the routine replacement of belts in your machines, either in your centrifugal blowers or in your production machines, do you think the belts used in your machines are sized correctly and for the machine running pattern? When the machine is running on star delta mode with a higher starting jerk, or while the machine is running on a VFD mode, the belts have a power carrying capacity and the power ratio of the belts to the rated power or the running power of the machine matters more here. So it is better to redesign the belts and pulleys in your machines, especially on variable torque loads like these blowers or the centrifugal compressor or the centrifugal pumps. It gives an energy savings of almost 10 to 20%, and on the production machines appreciably the savings is seen, and definitely depending on the torque and the speed of the given production machine, and definitely it reduces the vibration in the machines because of the loosely held classic V wheels, and these cocked belts and these resized pulleys, once in 40,000 hours it needs to be replaced. Once it is done, it gives an excellent sustainable specific energy consumption for the production machine also. Coming to the belts, what we are using is the Bureau of Energy Efficiency has given an excellent table regarding the motor drive transmission belt losses, and you can see especially on the classical V belts, you can see the losses almost from 8 to 15%, and almost I say up to 10 HP it's almost 2 to 6.8.5%, 2 to 8%. So the efficiency of the mechanical power transmission depends upon the grip between the pulley and the belt, further depends upon the coefficient of friction and the strength, the tensile strength of the belt. So definitely alignment is one area, and if the belt is sized correctly for the given power carrying capacity for the given belt, especially the cogged belts, energy efficient cogged belts, it definitely the self consumption of the belt transmission is less compared to the classical V belts. Definitely you can have a savings, appreciable savings. You can see a simple from a 2-inch see, you can see the this is a 50 HP blower. Instead of a 6-inch motor pulley, the 8-inch pulley, see 8-inch pulley the motor was running, and it was changed to 6-inch because the process needed only that much optimum pascals only, less pascals only and less flow only. Automatically from 26 kilowatt it dropped down to 11 kilowatt. This is what the sizing of pulley or the resizing of pulley once in 40,000 hours is definitely mandatory, especially in the maintenance of the belts and pulleys, and this gives an excellent savings whenever you are trying to optimize the static pascal for the given process and as well as for the load as such, static pascal and the flow for the given blower. This is on a foundry industry, and the MD has taken excellent initiative to achieve this on a sand mixer of 250 kg capacity. He was almost trying to replace the machine because it was a 250 kg rated machine. It was delivering only 170 kg, almost 20-25% the machine got derated. After replacing from the classic belts to the cogged belts as well as resizing the pulleys, the production went up in the machine by almost 215 kg, from 180 kg to 215 kg, almost 20% the production can be restored back to its rated capacity. This has been done almost some 5 or 6 years back, and still it is running like the same condition with an enhanced, with the restored capacity of the machine. It's see, instead of changing the machine costing around more than 10 lakhs, let us say, this costs around a few thousands, and this can definitely give you a lot of energy savings as well as productivity improvement, restoring the productivity. Coming to the pumps, I am just crossing over from motors to blowers to compressors to pumps. You always refer to the nameplate, pump nameplate, what is delivered. This is a 5.5 kilowatt pump, 7.5 HP pump, and the head range is around 18 to 29 meters, and the capacity is LPS is 18 to 11 liters per second. It's a circulation pump meant for the water circulation pump, and the nameplate of the pump definitely is mattering more, and how this can be optimized. You can see the way how this is optimized by replacing the internals, that is the pump is only replaced. Instead of a single monoblock pump, multi-stage monoblock pump has been replaced, and straight away 15% savings is achieved sustainably thanks to the Terry study, case study, especially on the foundries here. And many of the foundries have made use of it, and many of the foundries have started using these multi-stage monoblock pumps, especially for the furnace cooling and the auxiliary cooling applications. and definitely the monitoring and the piping changes involve system improvement as such. It is not only the pump internals like single stage monoblock to multi-stage monoblock, also it is the generation efficiency of the pump, but the piping also is a matter of concern in many of the industries where the choking or the scaling inside the pipe, say a 4-inch pipe becomes a 3-inch pipe due to heavy scaling inside, automatically the flow or the efficiency drops to 30% of the rated flow. This we have to keep in mind. Even you can see in many of your industries, you can measure the flow and you can see through either through a ultrasonic flow transducer flow meter, or if it is possible you can do a bucket filling method and measure it, and you see definitely the piping needs to be changed, or at least the piping flange, the expanded fitting at this pump suction and the pump delivery, where the flow of the velocity flow of the fluid, either the water or liquid or whatever it may be, it is smooth and it is low, and definitely this instead of the pump flange is only 3-inch, but the header is kept as 4-inch. One step header higher size is mentioned. Definitely the laminar velocity of the water is maintained. It's not turbulent at the pump delivery, as well as no strainage at the suction, and definitely this there is no you can see the pressure also not dropping at the suction, and as well as the pressure also not at the delivery point, it is not choked at the delivery, especially at the delivery where you have to go for an expanded eccentric expander pipe fitting at the suction and delivery to maintain a smooth flow across the pump as such. Not only for the pumps, this is applicable to axial flow fans and centrifugal fans also. If you see a normal typical van axial fan and that is mounted on a wall, and if it is not without this inlet bell mouth or an outlet discharge delivery cone, definitely this drops the rated flow by 6 to 10%. Also the tip clearance also matters more. It should be less than kept at 1% of the blade length of the given axial flow fan. The same flow enhancers is there available in the centrifugal fans also. Instead of having a simple let us say it's a 24 inches dia at the suction or 24 inches dia at the delivery, it needs to have an expanded suction or expanded delivery duct, so that the flow to the suction of the centrifugal blower is also smooth, and at the delivery of the centrifugal blower the flow is also made smooth and easy and with less and optimum static pressure as recommended by the OEMs. VFD is a common solution. Every industry is trying to make use of this, and we are also seeing a VFD put on 80 to 90% of the loading of the given machine. It is a loss to the machine only. But the VFD operated at 60 to 80%. I am just giving a correction here. It is not good to put a VFD for 30% or 40%. Any of your compressor or blower or a pump, it normally in general, I am just giving a thumb rule, it's in general the efficiency is almost around 60 to 80% of the loading. Definitely if the VFD is tuned to that 60 to 80% instead of 20 to 30% operation, let us see to it that the pump is sized correctly and the VFD is put, and 60 to 80% the loading is operated by the VFD, facilitated by the VFD. It will definitely give you excellent energy savings. The process is optimized, the static pressure and the flow is optimized. Automatic closed loop control of the process also matters more, especially in the heat transfer application. Lower the pressure gives a excellent heat resilience and a heat transfer, and the PID tuning features it can be made use in the VFD. Instead of just keeping a manual setting of VFD hertz, make use of the PID tuning features in your VFD. And depending on the variable, if it's a temperature variable, it's a slow variable, you need a PID, and if it is a pressure or flow or level, you need a PI control to operate the VFD in an optimum way to deliver the best results for the given process. All these aspects I have explained in all this, these 5 books have been published by me, and I have given lot of case studies in all these 5 books. Just to see the case studies, and whatever the case studies is delivered to you, it is done by you, implemented by you. You can just check the reference in the case studies given by the already done during our energy audit period and the post implementation during the energy audit periods. So ultimately, the energy conservation from the bottom of the pyramid, whether it is a zero cost or low cost, it's badly needed now for the industry as a cost cutting measure to improve the operating profit margin. Either it's a electrical demand control or an improvement in electrical motor, or the intermediate power transmission from the motor to the machine, all the pumping system improvements, optimizing the pressure, especially on the heat transfer applications, fan system improvements, the internals, see, are we having this aerodynamic profile on the existing fan? And just let us confirm it. HVLS fans definitely give an excellent delivery. High volume low speed fans on the centrifugal fans give an excellent delivery, and the efficiency is also excellent. Let us go for this type of aerofoil type and aerodynamic type profile centrifugal fans in our process systems as such. Lighting system improvement we have already done, and we have done changed over to LED, but still how to have an safe and see, the luminous depreciation should not be there. If you don't want to have luminous depreciation drastically down, definitely install a servo stabilizer on your MLSB, on your lighting circuit, to have a fixed luminous output, as well as the energy savings is also there. Lighting, LED lighting is operated safely, and you have a luminous depreciation in a slow manner, not in a fast and drastic accelerated depreciation of luminous efficacy does not happen as such. So steam system improvement, you try to give only the dry stream. The dryness fraction of the steam is very much important, around 5%. Let us say 95% the steam is dry and 5% only the steam is moist, and that is delivered to the process, especially on the indirect heating applications. So many of your applications call for excellent scope for energy savings, provided you monitor the input stage, at the intermediate stage, and at the exhaust stage. Ultimately, when the output stage is getting reduced or derated, these are all the areas we have to monitor, and where all the deviations are there, let us try to attend it, and let us try to see how this can be immediately attended to on a zero cost or a low cost measures, energy conservation measures, and sustain the efficiency of the given utility, either a blower or a compressor or a pump or a motor, whatever it may be. Thank you. Thank you. Thank you.